Hello everyone. My name is Erika Octaviani and I'm from International Program on Science Education at Universitas Pendidikan Indonesia. Today, as you can see, we're gonna talking about Newton's law. Newton's law, first of all, Newton's law is founded by Sir Isaac Newton. And Sir Isaac Newton has his own motivation quotes that he said if I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. And the next one we'll jump into the first Newton's law. The first Newton's law said an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So it means all object will stand still unless it has act or moved by the another force. And also the first Newton's law stated that all objects have inertia. What is inertia? Inertia is the tendency of an object to resist changes in its motion. And the more mass of an object has, the more inertia it has in the bracket, and the harder it is to change its motion. So inertia itself is a tendency of the object to resist any changes of the motion. And as you can see here, this is the formula of the first Newton's law, sigma F equal to zero. It means the first law of the Newton's law is the all of the force will be have the valuable of zero. The next one is the example from the real life from the first Newton's law. As you can see, this is the first example is a soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. As you can see on the picture, the ball has no force before it has been kicked by the soccer player. But after you are kicking it, the soccer player kicking it, then it has the force of the valuable of the force. And the second example is on your way to school, for example, on your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia and exerts a very small force on your car. So it means when you are when the since the bug has the what is it has the really tiny shape, then it has a little inertia on it. So it has kind of a little variable of the tendency. Next. Next is the second Newton's law. It said force equals mass times acceleration. Acceleration means it's a change in a velocity or a measurement of how quick an object is changing the speed. Force is directly proportional to the mass and acceleration. Imagine a ball in a certain mass moving at a certain acceleration, the ball will have a certain force. So it means when you the direct of this Newton's of the second Newton's law force, it will be goes proportional to the mass and acceleration. And as you can see here, this is the formula of the second Newton's law. Sigma F equals to m points A. M mean mass and A mean acceleration. And these are the example from the real life. At the first one, as you can see, something very massive or high mass that's changing speed very slowly or low acceleration, like a glacier, and can still have a great force. So everything which has a very high mass but has very slowly low acceleration, it will be have a great value of force. And the second one, as you can see here, the picture is a bullet, something very small or low mass that's changing speed very quickly or has high acceleration, like a bullet, can still have a great force. Something very small changing speed very slowly will have a very weak force. So by it means if everything with small or low mass but have have the high acceleration like a bullet, it will have a very weak force. And the next one is the third Newton's law. The third Newton's law said that for every action there is an equal and opposite reaction. So by it means like you need the action and the reaction. For every force acting on an object, there is an equal force acting in the opposite direction. So by it means like in the third Newton's law, there will be always opposite direction, not proportional. It's quite different with the second Newton's law. As you can see on the formula that the force that have been acted will be same with the minus force that have been reacted. So the formula is the F action equals to minus F reaction. And these are the example from the real life from the third Newton's law. First one, like what happens if you're standing on a skateboard or a slippery floor and push against a wall? You will slide to the opposite direction or away from the wall, of course, because you slide it away further from the wall. Because you push on the wall, but the wall pushed back on you with equal and opposite force. So it means when you are forcing it, when you give the force to go away from the wall, the action that you already give will be same as the reaction that that you will get. And the second one, why does it hurt so much when you stub a toe? When your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit the toe against it, the more force the rock exerts back on your toe, and the more your toe hurts. So it means like it's the same like the first one. All the action that you do will be have the sum of the reaction that you already gave. So that's all from me, Erika Octaviani, that have the explanation of the Newton's law. I hope you guys enjoyed. Don't forget to drop some assumption if and suggestion if you have any. Thank you very much.